A car of mass 1230 kg increases its speed from 4 meters per second to 21 meters per second in 24.5 seconds. So they've explained this. So the table below shows corresponding values of t and speed v. Using the values in the table, find the average acceleration of the car from 0 till 5.5. Okay, let's find the acceleration here. So for part 1, you can say u is 4 and v is 5 and t is 0.5 seconds and we need a. So we're going to use v is equals to u plus at. This gives us a is equals to 2 meters per second. Okay. And then it says do the same for this part. 16.3 to 24.5. Same thing. V is equals to u plus at. U is 19. V is 21. Time is the difference. 24.5 minus 16.3. 8.2. Acceleration would be v is equals to u plus a times 8.2, which comes out to be 0.2439. Okay, so we have the values of acceleration for part 1. Meters per second square is the unit. Okay. While the car is increasing, its speed and power output of its engine is constant and is equals to P, and the resistance of the car motion is constant and equals to R. Okay, so here's the car, here's the direction of motion. This would be the driving force. Driving force is equals to P upon V, and here's the resistance mentioned R. Okay. Assuming that the values obtained in part 1 are approximately equals to the acceleration at v is equals to 5. Okay. So they've averaged this out and they're saying that take v is equals to 5 and consider this to be its acceleration. And they've averaged these two, take v is equals to 20 and assume that this is its acceleration. Okay, now we have to use these and find the value of P and R approximately. So I'm going to use Newton's second law here. Forward force minus backward force is equals to MA. Let's apply the values P upon, let's take this first 5 minus backward force is equals to mass times acceleration. Mass is 1230 and acceleration is 2. Okay, let's call this equation 1. Do the same for this pair. P upon V minus backward force, which is R, is equals to M times A. A is 0.2439. This would be equation 2. You will solve these two simultaneously and get the value of P and V, which would come out to be okay. I've noticed another blunder here. This was 6. And if that's 6, this would be 6 and this would be 4. So we have to use 4 here to get the right answers. Otherwise, I was not getting the right answers. Now this should work. Let me check. Yes, now this should work. Okay, now P would come out to be 30799.2 and R will come out to be 1239.84. Rounded off to 3 significant figure, so power will come out to be 30800 watts and resistance will come out to be 1240 newtons.